We'll look at problem 4 now. It says we have to find the coefficient of a cube b raised to 4 and c raised to 5. This is a product in the expansion of ab plus bc plus ac raised to 6. So again, it's seemingly very different from binomial theorem, but I'm sure we can work out some way of transforming it into something we are familiar with. So let's see how to do that.
Yes. So the main problem by looking at this question is this two terms are multiplying in each term. Okay.
Right.
So that is AB plus BC plus AC.
Right.
And you must be worrying about how to get A cube B raised to 4 and C raised to 5 exactly.
Okay.
So we need to find a way to just express each term in each like the every term will contain only A, B or C.
Okay.
If we get that, we can just apply multinomial theorem and we'll get the final answer. Okay.
Right.
So how can we do that? So if we multiply and divide by ABC,
Okay.
the term,
Okay.
that is A.
ABC raised to 6 in fact.
Yes, exactly.
Okay.
Sorry. ABC whole raised to 6
Uh-huh.
into AB plus BC plus AC whole raised to 6
Okay.
by ABC whole raised to 6.
Right.
So this ABC will get into the bracket. Okay. So ABC.
So we'll have just 1 by A plus 1 by B plus 1 by
Yes,
C.
exactly. You predicted.
Okay,
1 by
and then
is-
obviously, since it is simply the sum of three quantities raised to an exponent, the multinomial theorem can be applied
Yes.
directly. Also, we have ABC raised to 6 directly there already. So then we'll have to check for, let's say, A raised to minus 3 should be there,
Yes.
and then B raised to
Because
minus 2 should be
here-
there.
Yes, exactly.
Okay.
Because here the power of ABC whole raised to 6 is 6 outside the bracket. Okay?
Right.
So if we need A cube, then we will have to find the power of 1 by A to the power 3.
Right.
So then only we'll get A cube.
Right, because out it's already 6, and if we find 1 by A cube, then we have 6 minus 3 equal to A, which will be, which will give us the degree of A to be 3, which is what we need. So we'll repeat this process for, all the three variables.
Yes. So in this series of expression,
Right.
we'll find the power of 1 by A
Mhm.
to 3,
Right.
1 by B to 2,
Okay.
and 1 by C to 1.
Right.
Because the power of C, A, and B are already 6 in the outside of the bracket.
Right.
Okay. So
So
it
we
will
are
get
also
minus
familiar
6.
with,
Will get divided by this A raised to 6 by A cube.
Right, and we are
we'll
also
get A cube.
familiar with a general expression, the general coefficient for multinomial theorem of a given power.
So it is n factorial by r1 factorial
Right.
into r2 factorial up to rk factorial.
Okay.
Rk factorial.
So here k is 3.
Yes, obviously. K
Okay.
is 3 and n is c.
Right.
6, okay. So the power of r1 is equals to 3, r2 is equals to 2, and r3 is equals to 1.
Right.
So we'll get the coefficient of 1 by a whole raised to 3, 1 by b whole raised to 2, and 1 by c whole raised to 1.
Okay, so
Yes.
so this shows that we can do it directly. We don't have to
Yes,
find
yes,
separate powers.
yes.
Nice.
So it will get to 6 factorial
Right.
by 3 factorial into 2 factorial into 1 factorial
Right.
into 1 by a whole raised to 3, 1 by b whole raised to 2, 1 by c whole raised to 1.
Right. This will be the entire term.
Yes.
Okay.
So this term will get multiplied by this one.
Right.
So we'll ultimately get the needed term is a cube into b raised to 4 into c raised to 5.
Right.
And what is the coefficient of this? Is 6 factorial by 3 factorial into 2 factorial.
Right.
So what is it? 6. So
6 factorial is 720.
Yes. Yes. 730.
720. in fact.
720 by 6 into 2.
Right.
So we'll get the
That
final
is
answer.
60.
Okay.
So again, I'll run through the question again. This is yeah, the solution here is 60.
So we'll divide by 12
Okay.
and we'll get answer as 60.
Right. So again, we verified that it was 60 in fact. So we were given, this expression AB plus BC plus AC raised to 6. We were asked to find the coefficient of A raised to 3, B raised to 4, C raised to 5. This is a product again. So we proceeded to, divide the entire thing by A, B, C whole raised to 6 and multiply with the same. So we ended up getting 1 by A plus 1 by B plus 1 by C raised to 6, which is
Yes.
something we can use the multinomial theorem upon, because it is just the sum of three quantities taken one at a time and it's been raised to an exponent. So the nice thing about applying multinomial theorem is that although you have to most people are slightly unfamiliar with it, but it gives you the exponents whatever however you want them arranged. It gives you it directly. You don't have to
Yes.
find one and then find another and then look for
Yes,
possible
this.
combinations. This
Yes.
formula already takes care of all the possible combinations of that category.
Exactly.
So we noticed that since we had a b c raised to 6 already, in some cases in fact in all the cases we had to decrease power. So for that it was nice that we divided by abc, because any power of 1 by a will be negative power of a, and so we can subtract that from 6. So we did that. So we figured that we had to just look for the coefficient of this term, and that is a very trivial task if you remember this formula here from the multinomial theorem. So we got that to be 6 factorial by 3 factorial into 2 factorial, and factorial values are something which it's always nice remembering, especially 5 onwards. So for example 5 factorial is 120. While doing combinatorics, this is something everybody gets used to. So therefore, as soon as you see 6 factorial by 3 factorial, 2 factorial, you don't even need to think about what is going on. Your, it should be like in 2 seconds you should be able to come out with an answer like we did right now, without even thinking about it or writing anything about it.
Yes.
So yeah, so those were some useful tricks, and you saw the method for solving this question. And see, the thing about such questions is that here we had to simply divide and multiply by a b c raised to 6.
And it was a very good step.
Right. That made our job so simple.
If we get that, the question is just following the steps.
Right. Okay. So, but there might be other problems, in which what you have to do at the first step to make it very simple is slightly different. I'm sure we'll have more questions upon that, in the lectures that are coming or in practice problems that you would have with you. So, yeah, this was problem 4, and we should look at the next one now. So we've reached problem 5, and the kind of problem you see here is probably the most common kind of problem that appears from this area of math. We have to show that c0 plus c1 by 2 plus cn by n plus 1, this is the general term, the sum of this series, we have to show that it is equal to 2 raised to n plus 1 minus 1 by n plus 1. And if you look very carefully, since there's an n plus 1 in the denominator and everywhere, it smells of integration in fact.
Yes. So by integration exactly we get n plus 1 at the denominator.
Right.
If we differentiate, actually integrate x raised to n with respect to x, so we will get n plus 1 at denominator.
Right.
This is the only property of integration which gives clear clue of this question to solve it by integration.
Right.
So what is the general term of this LHS of series of LHS is TR.
Right.
TR is equals to CR by R plus 1.
Right.
So CR plus 1 TR
Okay.
is equals to CR by R plus 1.
Right.
So how can we get this? Let's assume a binomial expression as 1 plus x whole raised to n.
Right.
To get up to here.
Okay.
So 1 plus x whole raised to n is equals to nc0 plus nc1 x raised to 1
Right.
plus nc2 x raised to 2 up to ncn x raised to n.
Right.
So just look carefully. How can we get this? If we just multiply it by dx and integrate it by integrate on both side of this
with respect to
equation.
x.
Yes,
Right.
it will exactly match with this.
Uh-huh. Let's check.
At least we get the binomial coefficient,
Okay.
coefficients of x as given in the LHS of equation.
Okay.
So just integrate then 1 plus x whole raised to n
Okay.
dx integral. So this nc naught plus nc1 x raised to n up to ncn x raised to n.
Right. You notice that as soon as we started, problem with this chapter, we went straight away to summation of series, because binomial theorem, as I mentioned at the beginning of theory, is something that is mostly application based, because it is so common a step in almost all problems, that most problems about binomial theorem are actually very practical problems, such as summation of series, which is what we've been watching. Okay, so let's
Yes.
continue.
So the two integrals are equal, means the constant is going to come in this picture, come in this equation. So to avoid that, we'll have to just put some limits to this. So x, let's say x raised to 0, x varies from 0 to 1 and 0 to 1. So if we do this, we will get exactly LHS of this equation to show the RHS.
Right.
Okay. So this is integration. So integration of 1 plus x whole raised to n will get us to 1 plus 1 by n plus 1 plus x whole raised to n plus 1 by n plus 1.
Right.
So we'll just put the limit 0 to 1 is equals to the we'll have to just multiply this dx inside the bracket.
Right.
So nc naught x dx. The integration of nc naught dx is nc naught x plus nc1 x raised to 2 by 2.
Right.
Like this. So plus ncn x raised to n plus 1 by n plus 1.
Right.
So here we can see the binomial coefficients are matching with this LHS of the
Okay.
expression.
Also, I just noticed that NC naught is equal to 1, in fact, and that is why you would have a 1 there. As soon as you substitute x equal to 1, there will be an extra 1 here, which obviously has gone over to the other side, and that is how we got to the solution.
Yes.
Okay.
Yeah. So we'll have to just put the limits. 1 by n plus 1 into 2 raised to n plus 1 minus 1 raised to n plus 1
Right.
is equals to nc naught plus nc1 by 2 up to ncn by n plus 1
Right.
minus 0.
Right.
So this is the LHS and LHS of the given expression.
Right.
And this is 2 raised to n plus 1
Right.
minus 1 by n plus 1.
Right. Which is where
Yes.
we wanted to get.
Yes. And this is the given RHS.
Okay. Right.
expression.
So we have to show that C naught plus C1 plus C2 plus dot 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 Cn by n plus 1 was equal to, in fact, 2 raised to n plus 1 minus 1 by n plus 1 here. So anyway, show that this expression is equal to this expression. Whenever you have denominators which have a pattern, it's mostly about integration. It might be about first integration, or it might be about integration, then some removal of some elements, and then integration again. Basically, the point we are trying to get across is that whenever you have a condition of mod z less than 1, for example, like that, or some other condition which removes restraints that you have to operate under, you can start thinking out of the box, and having that instinct that tells you instantaneously that this is probably about integration, because it has new denominators like that, and also this n plus 1, which has very few ways of appearing in the expression if the exponent is only n, because yeah, that is everyday life again. So what we proceeded to do was we differentiated, we actually integrated this equation
With respect to x.
with respect to x between 0 and 1, because we wanted to put values x equal to 1. So the correct continuous way of doing it is, put that value there already. Okay, so after that we proceeded to find, the RHS, to arrive at the RHS, and we did so in the next two steps. So this was problem 5, and we'll move on to the next one now.
So question number 6 says we have to find the value of C1 by C0 plus 2C2 by C1 plus 3C3 by C2 plus so on till NCN divided by Cn minus 1. Now we see that the question symmetrically progresses further on the expression. We see that C1 increases to C2 then C3 and the coefficient increasing 1, 2, 3 and so on, and similarly goes with the denominator. So we'll just look how to solve this question.
Yes. So after looking this series, what do we think? We have seen the coefficient, binomial coefficient in the numerator only. We haven't seen the binomial coefficient in the denominator. So how to handle this? Let's see the general term of this series. So TR is equals to, R into NCR by NCR minus 1 is equals to, we'll expand this binomial coefficient to get the simplified form.
To remove the term C.
Yes. N factorial by R factorial into N minus R factorial.
That is the formula of NCR.
Yes. And in the denominator, N factorial by N minus R plus 1 factorial into R minus 1 factorial. So if we simply simplify this, so we will get the N minus R plus 1 in the numerator and by 1 in the denominator after cancelling all this.
Exactly, by simply manipulating the terms you get this value.
Yes, and to find the value of series, the value of series is just summation of TR, where R varies from R is equals to 0 to N. So this is equals to summation of, we got the TR is equals to N minus R plus 1. So N minus R plus 1, R is equals to 0 to N. So this is equals to N plus 1, will separate this terms, okay. So R, this summation here and summation here. R
That's
is equals to 0 to N and R is equals to 0 to N. Since N plus 1 is repeating N times, so there we'll get N into N plus 1 of this term. Summation of N plus 1, R is equals to 0 to N will be equals to N into N plus 1 minus summation of N natural numbers, natural or whole numbers, because first term will be 0. So summation of first n terms will be equals to N into N plus 1 by 2. So ultimately we are getting the answer N into N plus 1 by 2. So this is the value of this given sequence.
Right.
Series.
So basically we see that in this question, it is not a very difficult question, okay. So basically we see that whenever we get a series which is not of a defined pattern, we basically try to find the rth term first and then simply put a summation in front of it, and then having the present formulas, we try to manipulate and see what can be done. And secondly, the important thing for all the questions of binomial theorem is that whenever we put a summation, we need to carefully assign the values, the minimum and the maximum values that the variable r can take. For example, there are many cases that in which it won't take values from 0, it would be taking from 1. So you need to carefully see where the function is defined and what the question is demanding.
Yes.
So this was question number 6.